Hey everybody, thank you for joining me. Today is our second lesson in Unit 2, and we will be looking at division of exponents. So the agenda is to complete the do now, which is a review on solving two-step equations, a little inquiry activity to develop the law, then you'll complete some class notes and some practice problems. Your homework tonight is on quizzes, and it is called Division of Exponents homework. There is also a paper copy posted if you do not have access to quizzes. I want to remind you the Unit 1 test retake is on Tuesday after school. So last class we looked at the first law of exponents, which is right here. When you're multiplying and bases are the same, you add the exponents. And we looked at the third law of exponents, which says when you're taking the power of a power, you multiply the exponents. Today, we're going to look at division. So the first thing we want to do is complete the do now. So I always ask students to write their game plan down, and I call it the GP. And that means the steps that you're going to do in order to get the answer to solve for x, and the order. So we undo addition by subtracting. So we would first need to subtract 8 from both sides of the equation. And then we would undo our multiplication by dividing. So we would need to divide both sides of the equation by 6. So the next thing I ask students to do is draw a line. And that line separates the equation into two separate parts, and it's meant to remind you that whatever you do on one side of the equation or one side of the line, you need to do the same exact thing on the other side of the line to keep the equation balanced. So we want to get 6x all by itself, so we're going to subtract 8 from the left side of the equation, and we're going to subtract 8 from the right side of the equation. So when we do our subtraction, 32 minus 8 is 24. And then 8 minus 8 is 0. And the only thing I have left on the left-hand side of the equation is 6x. I'm going to bring that down and draw my equal sign. So right now I have 6x equals 24. So the next part of my game plan says to divide by 6. So I'm going to divide both sides of the equation by 6. And x equals 4. Now I'm going to check my work. And to check my work, I take my answer of 4 and I sub it back into the original equation on the left-hand side. So I have 6 instead of times x, I'm going to have times 4 plus 8. And I do the math, and I want the answer to come out to 32. Well, I know 6 times 4 is 24, plus 8 makes 32. And since 32 equals 32, that equation checks, and the answer of x equals 4 is correct. Now we're going to go on to our inquiry activity. And what you have to do on the left-hand side of the equation is simplify each of these x into one exponent, and then see if you can develop a rule. Excuse me. So if I look at 2 to the 5th power, literally, that means 2 times 2 times 2 times 2 times 2. 5 2's divided by 3 2's. Now remember, 2 divided by 2 is 1. A number divided by itself is 1. So I have 1, 1, 1. And the only thing I have left is 2 times 2, or 2 squared, which equals 4. In example 2, I have 5 cubed divided by 5 squared. So again, I'm going to rewrite this in expanded form. And in the numerator, I have 5 times 5 times 5. 5 cubed divided by 5 squared. Now again, I can cancel. 5 over 5 makes 1. 5 over 5 makes 1. And the only number I have left is 5. On the last example, we can use the law of exponents for variables, just like we can do for numbers. And the big idea, we have to ask ourselves, are bases the same? If they are, and we're dividing, then we know we can subtract the exponents. And indeed, the base is the same because they're both x. Oh, let me write it out in standard form. And I'm hoping you're starting to see the rule. So we have x squared. So if you look at the first example, 2 to 5th power divided by 2 cubed gave us an answer of 4. And if you look at those exponents, 2 to the 5 minus 3 is 2 squared. And I know 2 times 2, or 2 squared, is equal to 4. If I look at 5 cubed divided by 5 squared, bases are the same, so I just need to subtract the exponents. And I have an answer of 5 to the 1st power. I don't typically write a 1 if my exponent is not written there or the directions don't ask us to simplify it. You could leave it like that, but you want to try to get in the habit of not writing the phantom 1. And then on the last example, we had x to the 4th power divided by x squared. So x to the 4 minus 2, which is x squared. So I'm hoping that you can see when you are dividing and bases are the same, you subtract the exponents. So that is our inquiry activity, and I'm hoping that you see there's no magic in math. It all makes sense. So now we're going to take some formal notes, and we're going to look at the division property. And to divide powers with the same base, you want to type in here subtract. Subtract the exponents. So let me write this a little neater. So 9 to the 6th power divided by 9 to the 4th power. Well, 9 to the 6 minus 4 equals 9 squared, which is 9 times 9, or 81. So you really want to always subtract where the larger exponent is, because that will keep your exponent positive. So if we look at the second example, m to the 4th power divided by m to the 6th power, the larger exponent is in the denominator. So we will subtract in the denominator, which means we will write a 1 in the numerator, and we have m to the 6 minus 4, which is 1 divided by m squared. Okay, so we do have some practice problems, and what I'm going to suggest you do is you do them on a separate piece of paper and maybe take a picture of your work and send it to me in this Google Classroom. So for problem number 1, we have x to the 7th power divided by x to the 5th power. Well, bases are the same, And we're dividing, so we're going to subtract the exponents. So this is x to the 7 minus 5, which is x squared, and that's our final answer. On example 2, we have 4 to the 5th power divided by 4 squared. So again, bases are the same, so I'm going to subtract where the larger exponent is, which is in the numerator. So 4 to the 5 minus 2 is 4 cubed. Now, 4 cubed can be written in standard form, and it means 4 times 4 times 4, which equals 64. Okay, example number 3. We've already done 2 examples where we're dividing where the larger exponent is, which happened to be in the numerator. But this time, the larger exponent is in the denominator. So again, we're going to write it as 1 in the denominator and 3 to the 4 minus, well, how many 3's were in the numerator originally? Just one of them. So it's 3 to the 4 minus 1, which is 3 cubed. And hopefully you'll remember that as 1 over 27. Okay, so problem number 4, we have 24 x to the 6th power divided by 6 x to the 6th power times x to the 4th power. So the first thing I'm going to do is divide the numbers separately and then organize the variables separately. Okay, so this is 24 divided by 6, which is 4. And then x to the 6 minus 4. I'm going to do my subtraction in the numerator. So my final answer is 4x squared. Okay, problem number 5. If you look at 5 and 6, they're the 2 laws that we looked at yesterday. When we're multiplying and bases are the same, what do we do to the exponents? Add them. Very good. When we're multiplying and we're taking the power of a power, we multiply the exponents. So in example number 5, we're actually going to add the exponents. So it's x to the 7 plus 5, which is x to the 12th. And the next one, we're going to do x to the 7 times 5, and I usually put a little dot there so people can see that I'm multiplying by 3. So the 7 times 5, which is squared. So we have x squared. Oh, I'm sorry. 7 times 5 is 35. Oh, boy, am I tired. So you can see these answers are very different. Okay, so the next thing I want to do is take a look at the last couple of problems, and this is a review of what we had done last class. And if you remember, we have 7x cubed, and they're separated by multiplication, so we're going to draw a line there. And in the second parentheses, we have 6x squared. Again, they're separated by multiplication. So The commutative property says that order doesn't matter, so I'm going to rearrange my numbers, 7 times 6, and then rearrange my exponents, which are x to the third power and then x to the second power. So when we're multiplying and bases are the same, we add the exponents. So 6 times 7 is 42, and x to the 3 plus 2 is x to the 5th power. And then the last example. On this one, I can see my number of downstairs is much bigger than my number, much larger than my number down in the denominator. So this fraction is going to be less than 1. And I'm going to bust up the numbers and then the variables. And I can simplify 936 as 1/4. And when I'm dividing and bases are the same, I subtract the exponent where the larger exponent is, and this time it's in the numerator. So I have 1/4, and then I have x to the 3 minus, m to the 3 minus 5, which is m cubed. And that would be our final answer. Okay, so the next thing I'd like to do is take a look at the word problems. And a lab technician draws a sample of blood. The cubic millimeter of blood contains 22 cubed white cells and 22 to the 5th power red cells. What is the ratio of white blood cells to regular? I need your all right. So a lab technician draws a sample of blood. A cubic millimeter of the blood contains 22 cubed white blood cells and 22 to the 5th power red blood cells. What is the ratio of white blood cells to red blood cells? Well, a ratio is a comparison of two numbers by division. So I'm going to write my ratio in words first. It's white to red. And the white blood cells, to red blood cells. So we're going to subtract in the denominator. So we have 1 over 22 squared. So we want to write it in exponent notation and then without exponents. So we would have to multiply 22 times 22. Which is 484. So it's 1 to 484. All right, the next problem says the number of 5-letter words that can be formed in the English alphabet is 26 to the 5th power. The number of 3-letter words that can be formed is 26 cubed. How many times more 5-letter words can be formed than 3-letter words? So we're going to take our 5-letter words, which is 26 to the 5th power, and we're going to divide it by 26 to the third power, which equals 26 squared. So 26 squared more words. And again, I want to multiply 26 times 26. And that gives me 676. And that would be my final answer. All right, well, I hope that you found this video helpful. Please go on and start working on the quizzes review of today's lesson, which is dividing exponents. Thanks, everybody. Have a great afternoon, great day.